ఓపెన్ చేస్తున్నా ఓపెన్ అవుతుంది కానీ అక్కడైతే లింక్ మీద ఏమో
గుడ్ మార్నింగ్ అండి. గుడ్ మార్నింగ్ చెప్తున్నా.
గుడ్ మార్నింగ్ సార్.
ఓకే, వినిపిస్తుందా?
ఎస్ సార్.
Okay, so I think tasks completed in tasks and functions topic. Tasks completed. Now come to the functions. So as we discussed in the first class of this topic, the functions have more limitations than the tasks. Okay, so that means as I said, the functions should be included in between two keywords. One keyword is function, another keyword is end function. Okay, this is one keyword. 1 minute. This is one keyword and this is another keyword. So whatever the function program is there, whatever the function code is there, whatever the function routine is there, that you should be keep in between these two keywords, function and the end function. Okay, and moreover, so once again recall the function main limitations. The function will return only one value. Okay, function will return only one value. And second one is there should not be any delay, timing delays or event control delays. There should not be any delay are allowed. And only input arguments allowed. But task allows input, output, in out also. And moreover, so if all these conditions, any condition or all these conditions presented, the task can be performed. But here these are the strictly prohibited. But these are okay for the task. Got my point? Hello, understand?
Yes sir.
No answer. Okay, so function declaration and invocation. How to declare a function and how to call it. What I told you, how to declare the function, how to invoke it. Okay, so the syntax is like this: function, write the routine, and what is that one? Close by end function. Okay, so I think range or type. This is the function. In brackets you can write some range or type, name of the function, like that. Function space name of the function. See, here is something we want to discuss here. 1 minute. This is the name of the function. That means, as we discussed what I said. So every function or task, it must be have what? It's identity. Okay, identity. Identity means name, object name. Like here is a function name or task name. Okay, and see, it is declared the output of the function is passed back by setting value of the register name of the function. Wherever in the design program, if you want the value which is computed by the function, you can write the name of the function there. Understand? So the function, I told you, it is a small program which can be computed separately and passed to the main program, main HDL code. So wherever in the main HDL code, wherever, whenever or wherever the function output is required, where you should write the name of the function. Okay. At the end of the function execution, as I told you, the return value is placed. Okay. So where the function was invocated. Invocated means, I think, called in the main program. So by writing the name of the function, you can call it. So call it means what? The entire program will not call. Only the value which is computed by the function will be called. Okay. The range or type is an optional. May be used or may not be used. Okay. Range means what? I think scalar or vector. Okay. Functions cannot invoke other tasks. Functions cannot invoke other tasks. Okay. They cannot be invoked by other functions. Functions can be invited by the other functions, but it cannot be invoked by the other tasks. So for example, here is a one example is there. So the first example model, that means parity calculator. Yeah, already we computed this one. Return value is 1 bit, 1 or 0. Okay, this is one first program. Second program is 32-bit left right shift register. Okay, and returns 32-bit shifted value. Okay. చెప్పేసానా చెప్పాలి కదా చెప్పావా ఓకే ఇది అయిపోయింది టాపిక్ ఇంక నెక్స్ట్ ఏమనుకున్నావు యూస్ఫుల్ మోడలింగ్ టెక్నిక్స్ ఇదేనా okay so useful modeling techniques. Yeah, you know about the what is the procedural continuous assignments. This already we discussed. Procedural assignments which comes under the construct procedural assignments and always and initial blocks. We will write the some sort of statements. Those are called the procedural assignment statements. Okay, so that already we discussed. Okay, procedural assignments assigns a value to a register. Got my point? Procedural assignments. For example, assign. Okay, not assign. For example, y is equal to a plus b. So this y may be a net or a register. Okay, so a plus b will be computed. And that value is assigned to the what? Yes, that is the procedural assignment. Y is a register. So the values stay in the register until another procedural assignment what? So puts another value in the register. As I told you, the register holds the value until new value is overridden. Once the new value overwrite, then the old value will erase. It was gone. Okay, so there are procedural statements which allows values of expressions to be driven continuously onto a register or a net for limited period of time. It is a period of time, simulation period time. How much time they allowed to run, to assign, to compute. As I told you, y is equal to a plus b. Okay, so here a and b values first read, then compute the a plus b, then that value will be what? Assigned, means written right into the y. I told you these three steps while we discussed about these procedural statements. If you take a statement y is equal to a plus b, okay, or y is equal to something, or y is equal to a x plus or with b, whatever it may be, first a b value should be read, then compute, then write into the y. So suppose if there is no time delay, this is going on. How much time they allowed to do this process? So this will be allowed for a limited period of time. Okay. So procedural continuous assignment behaves differently. They are procedural statements which allows a value of expression. Okay. Procedural continuous assignments override existing assignments to a register or an act. Okay. They provide an useful extension to the regular procedural assignment statements. We'll see that one. Okay. So there is some extension is there for that. Is saying what is the extension? We'll see that. Assign and de-assign. Actually, we know assign. Assign statement we are actually used in the data flow modeling. So what is the difference between the assign and what is that one? Behavioral assignment and data flow assignment is, so data flow assignment continues to do the function, but behavioral assignment will do only the whenever the signals change. Okay, so the assign and de-assign. So they are used to express the first type of the procedural continuous assignments. Okay, so the extension is, what is the keywords? Assign and de-assign. Okay, so what is that one? The first type of procedural continuous assignment is assign and de-assign. అక్కడ క్లాస్ వెళ్ళిపోయారు పక్క రూమ్ లో ఏమవుతుందా ఇన్ కేస్ ఆఫ్ మీకు లేదు కాబట్టి ఆ రూమ్ లో వెళ్ళిపోయింది The left hand side of the procedural continuous assignments can only be a register or a concatenation of registers. Left hand side, as I told, y is equal to a plus b. Assign y is equal to a plus b. Left side is y. Y is what type? It is a register or a concatenation of register. Concatenation of registers, two registers. Okay, it cannot be a part or a bit selection of a net or an array of a register. So earlier I told you this type, what is there in continuous assignment statement? I told you. Okay, what is that? In continuous assignment statement, this is allowed. Left hand side may be a what there is a bit selection or a bit selection of a net or an array of a register. That is okay, but here in procedural it is not allowed. Okay, so that procedural continuous assignments override the effect of regular procedural assignments. Procedural continuous assignments are normally used for controlled period of time. Okay, see, this is an example of DBPL of asynchronous reset. Okay, we'll do using of this assign and de-assign. So this is the negative edge triggering. You know about this statement, module space identifier. What is the identifier here? Edge underscore DFF. So what are the signals? This is our DBPL. Okay, D is one input and clock is one more input. Clock CLK and Q is output. So maybe Q bar is also one of the output. Okay, And he said two more signals given. One is reset is given. This is the reset, maybe. Or ST, or you can write what it may be, no problem. So RST or reset, no issue. Yes. So here inputs are these three: reset to D and clock. Yeah. Output and register is 2. So these two are outputs and registers, Q and Q bar. Okay. Got my point? So now start your always block. Okay. So because negative edge of the clock. Negative edge of the clock. So with respect to the negative edge of the clock, okay, Q becomes D and Q bar becomes D complement. And so now with respect to the reset, I'm talking always at the rate of reset. So override the regular assignments to Q and Q bar whenever reset goes high. Use of procedural continuous assignments. So this is the Q and Q bar values are updated by this clock. So those values can be overwrite from the reset control. How means, look here. See here, if reset is high, what is it? Override the regular assignments to Q and Q bar with the reset is high. So that whenever, if this is true, that means reset is 1, then some statements should be executed. What statements begin? Assign Q is equal to 0 and Q bar is equal to 1. Reset means 0. Okay, this is, I think, so if this is active, whatever the earlier values of the Q and Q bar is changing. If this is false, I think those values are keep as it is. And here you see, these are the assignment statements. Continuous assignment statements. Okay. Generally, we found this one is in the what? Data flow modeling. So, and if this is false, if reset is not 1, then else begin deassign Q and deassign Q bar, which means if the reset goes low, remove the overriding values by what? Deassigning the registers. After this, the regular assignments Q is equal D and Q bar will be able to change the registers on the next negative edge of the clock. This is so that no change deassignments. Deassignments no change. Okay. So if the reset is goes low, what happened? Removes the overriding values by the deassigning. Okay. Overriding value means it will change the values. So this is, yes, and module. This is the what? First, what is that one? Extension of assign and deassign. And second one is force and release. Second one is force and release. So you can use them. Okay, the keywords force and release. Yeah, the force is one keyword, release is another. Use it to express the second form of the procedural continuous assignments. Earlier, there is no continuous. Now, the continuous term is added in the procedural assignments. We know the procedural assignment, but this is the mixing of both procedural and continuous assignments. So at the beginning of the behavioral modeling, I told you the difference between the continuous assignment and what? So behavioral assignment difference. So now what I'm further some kind of useful things. I want to mix up both. So that is called the what? Procedural continuous assignments. PCA. What are they? The first one is assign and deassign. Second one is force and release. Force and release. So they can be used to override assignments on both registers and nets. Both registers and net. Okay. So force and release statements are used. Okay. And now we'll see the force and release on registers. Yeah, this is the syntax. Syntax is like this. See, here is the syntax. So module stimulus. So initial, so edge trigger piplaf, dpiplaf. So you know all the things. Okay, earlier same. Now initial and begin. And here is some statements like force. What? Q is equal to 1. Okay, release. What? Q. So what means? These statements force a value 1 to the dpiplaf in between the what? 50 and 100. 50 and 100. Because this 50 plus 50 is 100. Because you are using the keywords begin and end. These are the serial type. Serial type means time will be added. The first statement time is 50. Second statement time is 50. So 50 plus 50, 100. At 50, what? So logic 1 is forced into the dpiplaf, and the same value you are releasing or removing at the 100, time 100. Okay, regardless of the actual output of the dpiplaf. So without knowing or based on the operation of the dpiplaf, you want to make the Q as 1 and Q bar as 0 some period of time. So like that, for limited period of time, to force and to put some values. So what happened? You can use assign and deassign, force and release. So then little bit more statements ka simple ga ayipotundi. Yeah, that is a force and release on a register. This is the force and release on net. So here is another example based on net. Top assign out is equal to A, B, and C. So this is the out is a net here. This is the net. This is the net. Of course, all this A, B, C also nets. Okay. Suppose A is equal to 1 and B is equal to 1 and C is equal to 1, or A is equal to 1, 0, 0, because it's a single AND operation is there, which means bitwise AND operation. So B may be 1, 1, 0 and C may be 1, 1. It is just A and B. I don't know what is the A, B and C range. Okay, if all are 3 bits, then it is nothing but the 3-bit. That means 9 inputs. So AND gate. Yeah, A is 3 bits, B is 3 bits, and C is bits. So finally, you will get the what? 1 value. So that is stored here. So not 1 value, 4 values will come. 4 values will come because this is the like 3 values will come. Sorry. So for A, so I think this is equivalent to, for example, all are 3 bits. Then A, the one AND gate is this like this. It will generate LSB, 1 LSB, and another one, the middle bit will generate. Another one, the MSB will generate. So like these 3 bits are what? Given to this net. Okay. So that means assign out is equal to A and B and C. Compute the end of the between A and B values. That value will be what? Assigned to the net out. What is the net? Net variable. Net name is what? Out is a net name. So now initial 50 force So now you are using this one, force and release. Out, some other value will be assigned to the out at time t is equal to 50. So at time t is equal to 100, what? Release the whatever the value assigned and back to the same value. This is force and release. So force and release can be used for both register and net. Next to and then overriding parameters. So I think parameters can be defined. Parameters, parameter declaration, Okay, parameter declaration, suppose count is equal to 10. Parameter space count is equal to 10. So wherever you wrote what count in the design module, its value is 10, fixed. That is the parameter. Okay. So overriding parameters. I'm talking about parameters. Parameters can be defined in the module definition. The first part is the module definition. Okay, that we know. So parameters. What is it? However, during the compilation of Verilog modules, parameter values can be altered separately for each module instance. This allows us to pass a distinct set of parameter values to each module during the compilation, regardless of predefined parameter value. So earlier we know the value is predefined. So the value won't change. But now, because of this overriding parameters, the parameters value can be what? So you can alter. Okay, understand or not? During the compilation of Verilog modules, parameter values can be altered separately for each module instance. Okay, what is a module instance? 4-bit adder. So full adder of 0, full adder 1, full adder 2, full adder 3. These are the module instances. So this allows to pass a distinct set of parameter values. Okay, there is a different set of parameter values. Clear? Okay, there are two ways to override parameter values. One is the diff parameter statement or through module instance parameter value assignment. There are two things are there. One is the def parameter value statement you can use. Otherwise, one more thing is there, that is the module instance parameter value assignment. Okay, first we talk about the def param statement. Def param, this is a keyword. Okay, so the parameter value can be changed in any module instance in the design with the keyword this one. Def parameter value. See, here is an example. The example is module hello world. Yeah, this is the name of the module. The parameter value is 0 and parameter variable is what? ID underscore num, identification number. Initial, here you can write the display hello underscore world ID number is equal to what? Decimal value. Clear? Yeah, these two things are nothing wrong. No novelty. That means they are not new. And this is the top module. Okay, see, here is a def param. Okay, def param. This is the w1.id num. What is ID underscore num? Is a parameter. Now I'm making w1 dot this parameter value is equal to 1 and second one is 2. Okay, now yeah, so now see what is that one? These two parameters are defined newly. Now instances, these are instances I told you. Hello underscore world w1, hello underscore world w2. Hello underscore world is there now? Yeah, the above the program is there. Okay, so that is one. W1 means this is and this is at the module. This is the def param. Okay, so generally ID underscore number identification underscore number value is ఎంత అనుకున్నాం మనం ఫస్ట్ బిగినింగ్ లోన 0 అనుకున్నాం, బట్ హియర్ చేంజ్డ్ 1 and 2. ఓకే, సో నా ఏం జరుగుతుంది అంటే 1, 2 డిస్ప్లే అవుతాయి. జనరల్గా ఏ డిస్ప్లే అవ్వాలి, ఇంతకుముందు 0 డిస్ప్లే అవ్వాలి, ఇప్పుడు ఏమవుతుంది 1 and 2 డిస్ప్లే అవుతుంది. The module hello underscore world was defined with the identification number 0. However, when the module instances W1, W2 of the type hello underscore world are created, their ID number values are modified with the def param statement. If we simulate the above design, we would get the following outputs 1 and 2. Multiple def param statements can appear in a module. Yeah, so I think here is two things, sir. Two def param. What is that one? This is the one def param. This is one more def param. I think he put comma. So otherwise you can separate with this one. Okay. So the first one is assign and decision. Next one is force and release. Next one is def param. That is one type of the parameter override. Okay, so module underscore instance parameter values. Okay, condition compilation and extension component condition. Okay. Okay, exam is on Tuesday. Thursday. Okay. At what time? Okay. So some chart box is there. Okay, you tell me now. Exam, how many are presented offline and how many presented in online? Karthik.
Sir, Karthik is present, sir.
Present in class గురించి కాదు మాట్లాడుతుంది. ఎంతమంది ఆన్లైన్ లోకి వస్తారు ఎగ్జామ్ రాస్తారు, ఎంతమంది ఆఫ్లైన్ లో ఎగ్జామ్ రాస్తారు?
సార్ అంటే నాకు థ్రోట్ ఇన్ఫెక్షన్ అయింది సార్.
సార్ మీరిద్దరే ఉన్నారు ఆన్లైన్ లో, మన వేరులేరు ఈరోజు.
ఐ డోంట్ నో సార్.
యు డోంట్ నో. సరే ఏంటి అది మరి ఎప్పుడు
సార్? అంటే ఆ రోజు కన్ఫర్మ్ చేస్తాను సార్. అంటే థ్రోట్ ఇన్ఫెక్షన్ వల్ల ఫీవర్ వచ్చి తగ్గుతుంది సార్. సో ఏమైనా ఫీవర్ అలా వస్తే ఆన్లైన్ చేస్తాను, లేదంటే క్లాస్కి వచ్చి రాసిస్తాను సార్.
సరే సార్, మీరు డిసైడ్ చేసి చెప్పండి సార్.
ఓకే సార్.